Okay, so we're going to talk about real-time notifications. So that's it's a loaded term. I think we've heard that phrase already a few times today, but real-time notifications, specifically in serverless environments. Really exciting topic. There's a lot of education that I'm excited to let you know about today. So we're going to talk about quite a few things. We'll talk a little bit about Momento, of course. That's why I'm here. But we're going to level set. What are real-time notifications? What do I mean? What are they not? We're talking about architecture, things that you may have built in AWS to facilitate real-time notifications. We'll talk about one specifically that I've built, have some battle wounds from. We'll talk about what is a new way you can use Momento to make it better. I'll make that bold claim. We'll talk a little bit about how a serverless service is built. So I'm actually going to go in and show some architecture diagrams of what the back end under the hood serverless looks like. Spoiler alert, something we already know, there are servers. And then we're going to talk about some really cool use cases, some things that you can build on top of real-time notifications and how easy Momento makes them. So talk about Momento, talk about us being one of the cool guys. Really the big thing about Momento is we push serverless. And if you guys have been a part of the technical community for any length of time, it comes in waves. Whether or not people like the term serverless, whether or not it has a lot of value. But we talk about it in the non-markety way. We talk about the capabilities that we can provide to end users, things like elastic scalability, fast, best practices built in. You don't have to configure everything. You don't have to be a domain expert, and then the pay as you go kind of thing. So that's what we're looking at when we're talking about serverless. So like Eric said, we have a few different services that we offer, again, all serverless. Started off with caching, just serverless cache. Think about that as temporarily storing your data with an elastic scalability that you don't have to manage. We moved on to topics, which is real-time notifications, which is what we're here to talk about today. And then in August of this year, we announced a serverless vector index service as well. So can power your AI workloads if you like. And some of the guiding principles, like why Momento builds what it builds and what drives us when we get out of bed every day, is making things fast, easy, simple, lower the barrier to entry so you can experiment and get to production as fast as you can. About myself, so my title at Momento is Ecosystem Engineer. I think I'm the only one in the world with that title because it is a made-up title. It's a combination of developer advocacy and solutions architecture. You know, startup life, you do a little bit of everything. So I do a little bit of everything there. I'm a serverless hero. I was named a hero in Q3 last year. Been having a lot of fun with that, educating people, talking about serverless, bringing serverless to the hands of many. A big part of my identity, I do live on a farm. That is actually true. This is actually branded material that I'm wearing for my farm. If you're ever in the Dallas area and you need eggs, come talk to me, please. If you have seen anything from Ready Set Cloud, it's a podcast, a blog, it's a newsletter. That's me. That's my brand. That's something that I run. I have one exception. Only one piece of content on Ready Set Cloud has been published by someone not from me, and it's from that guy right there. So thank you, Matt. I was on an anniversary trip in the middle of the ocean and said, hey, Matt, can you send a newsletter for me? He said, sure. So thank you. All right, let's talk about some definitions. Let's talk about what is real-time notification, because there's a lot of confusion and a lot of assumptions on what real-time notifications are and some of the things kind of tangentially in this space that lead to misinformation and shutting down of this conversation in general. So when I say real-time notification, I'm going to talk about event-triggered, I hate using the word to describe the word, but notifications, events, very fast, very low latency, and then the opinion of this presentation is two-way. Now, real-time notifications do not have to be two-way, meaning something from the client to the server and the server back to the client, but for the context of this conversation, it does have to mean that. So we'll talk about why that's important. So here's the big piece of education that I really want you guys to take away. Now, when I was an enterprise architect a few years ago, the product owner of a new product we were working on said, hey, I need you to build a real-time application. I want an app where if somebody's interacting with it, everybody else sees it actively. And I was like, oh, great, so you mean WebSockets. That's what real-time notifications are, WebSockets. And while that's technically not wrong, it's not the complete answer. WebSockets are a very specific type of real-time notification. So it's like that saying where they say all squares are rectangles, but not all rectangles are square. More or less the same thing. So WebSocket, again, very specific, goes over the WS protocol. It's a stateful connection from the client and the server that shares one or uses one single TCP connection for communication. So it's like a phone call, basically, when we're talking about stateful communications like WebSockets. When you have a phone call connected, you know when the other person is there and you know when they're not. Now, a push notification also is something that I hear a lot of confusion around. People hear real-time notifications, they think, oh, push notifications and WebSockets, those are all the same thing. No, that's not, again, not correct. A push notification is a server-side message. So it starts on the server side and it goes one way down to the client. Conversely, from WebSockets, they can go both ways. You can send messages back up from the client, but push notification is one way. So like a letter, they're completely independent and you don't have any context about any of the previous messages that have gone over the wire. Now, one other thing, I've mentioned this a couple different times, but I want to talk about the definition of these two things. When we talk about stateless and stateful connections, a stateful connection is like that phone call. You have a live person on the other end or a live entity on the other end of a stateful connection. Conversely, a stateless thing, you don't. So those are communication mechanisms like webhooks or things that you don't have information about who your consumers are. It's just, here you go, ship it over. And we know a lot of things that are stateless, like SNS is a really good example of a stateless messaging system. Okay, so that's the quick level set. Let's talk about architecture. Now, when we're talking about real-time notifications and event messaging, these are the ones that we typically know about. And they all have their very different flavors. There's a whole bunch of different ones because there's a bunch of different ways you can tackle them. Now, if you remember, at the beginning I said we're going to talk about two-way communications. So that actually eliminates SNS. SNS is a one-way. It's that stateless server to fanned out number of subscribers. And so we have AppSync, IoT Core. If you've been over to Serverless Espresso, it uses IoT Core for real-time notifications. And then API Gateway. Now, specifically, we're going to look at the API Gateway version of real-time notifications because it's the one that I've built before. And that's the one that I know the most and I have a lot of opinions on because it has hurt me in the past. So we're going to talk about what that actually looks like and talk about what real-time notifications are with WebSockets with AWS. So on the left-hand side of the screen, you see the connection management portion of a WebSocket system. As simple as I can make it, you have your connect and disconnect Lambda functions, which are triggered when somebody actually connects or disconnects to your WebSocket. And then you have another action in there for basically subscribing to topics. Now, WebSockets themselves don't have the concept of topics, so you kind of have to build that in yourself. The other parts of the architecture, of course, as part of any production-ready solution, you have auth that sits on top of API Gateway that validates tokens that come in. Only on the connect, WebSockets do not validate every single request. They validate the connection, and then you're authenticated. But then you have to go and you save connection information and associate that to users in DynamoDB or whatever your database is of choice. Really, the point to note there is the API Gateway doesn't manage your connections. It keeps them, but you have to figure out who knows what, who wants what. It's a whole big thing. And so when I've implemented this before, I implemented this with a data model that is very similar to what I have down at the bottom. So somebody connects, I drop an item in DynamoDB. It says, here's this connection identifier that I can send to API Gateway, and here's the user that is on the other end of that. And subsequently, when somebody makes a call to say, hey, subscribe me to this topic, for example, give me a notification when somebody posts about goats or posts about chickens. Say, okay, sure, I can do that. So I save another record about the topics that these people, these connections care about back in DynamoDB. So when it comes time to actually send that person a message, we have this workflow that you see up in the upper right where there's a event bridge rule, it goes into SQS, and then Lambda pulls that. It does a query on DynamoDB for everybody that cares about that type of event. Let's say we have a goat event, so we're going to care and look up everybody that wants to learn about goats, and then we'll iterate over each one of those connections and pass that payload down to them. So really, it's a lot. There's a lot to it. I think there's like 12 boxes on that architecture diagram right now, and that's about literally as simple as I can make it. And I've been blogging for like 5 years. I've written hundreds of articles, and WebSockets, specifically this type of architecture, is the only blog series that I've ever written because they're so complex, because there's so much to them. There's just so much that you can do wrong and right and inefficient. It's probably not good. There we go. So let's talk about sending a message to that. So we've talked about how complex it is, but all of that was literally just connection management. That's all it was. It's not actually sending a message. So what happens when you actually want to send a message? So we have our standard data flow up there at the top, and it doesn't really matter what the domain is. We'll just talk about farming. API Gateway Lambda will do your very basic, very standard serverless workflow. So Lambda, Dynamo, we have a stream that reacts to the deltas in DynamoDB, and then we have a Lambda function. And what I've done in the past is I have this stream handler that will index the change data in OpenSearch, and subsequently it will also publish an event to an event bridge that will trigger that workflow and send a message back down, all the way down to the client about goats. And that's a lot. That really is a lot. If we take a step back from it and just look at it in general, sending a message, being able to connect to a WebSocket, subscribe to a topic, and receive a message is 7 Lambda functions, 600 lines of infrastructure as code, 12 boxes on the architecture diagram for just that one piece of functionality. I have kind of in there because is it functionality? It could be a non-functional requirement. It could be a functional requirement. It really depends how you slice and dice it. That QR code points to an open source repository that I have that is this. It's this entire implementation. You can, I know everybody here uses SAM for their deployments. So it's a SAM template. You can just do SAM build, SAM deploy, and you get all of this out there in the cloud. But I would encourage you to not do that yet, because we're going to talk about the better way first. And I'm going to frame what we're going to talk about right here. So, very strong opinion that we live in an age of just do it for me. Meaning, if there's a managed service out there that does something that I want, I'm going to use it pretty much every time. Why would I rebuild something that there's an entire team of dedicated developers out there that is consistently improving, maintaining, and has domain expertise on that I don't have any of that, right? If I build it myself, I'm going to have to maintain it. I'm going to have to build this domain knowledge around WebSockets that I don't really care about because I'm an app dev. I care about solving business problems. I don't care about infrastructure around WebSockets. So instead, the easier way, this is going to sound like a sales pitch, I swear it's not, very excited about it. You can use Momento Topics, which is basically managed everything that we just look at. So instead of WebSockets under the hood, it actually uses gRPC for these stateful connections. It feels just like a WebSocket, but it's not. And it just provides really fast, really good, scalable connectivity between producers and consumers. We'll get into that in a second. But really, I want to frame this one as managed real-time notifications. I don't want to do all of these really big architecture diagrams. I just want one box that says Momento and have that handled for me because they have the domain expertise, not me. And what's nice about that is that it gives you the ability to really focus on solving the business problems. If you guys attended Sam's talk, you could figure out like who's the producer, who is the consumer, not where in my architecture are these things coming from. It's where's the source, where's the business that is driving these events, and what do I need to do to react to the event? So I'm not building up all these different architectures around all that. It really helps you focus and keep a tight lock on the domain that you work in. So let's look at this again. Nothing's changed. This is just the big, way too much implementation of a WebSocket. And we don't like it. We're going to throw it away. What we're going to do is we're going to bring back just that data flow. This doesn't change. I think we've all implemented a workflow very, very similar to this. But there's one thing in here that I don't really like. And if you guys have caught it, it's that Lambda function at the end. Best practice really is to have Lambda function dedicated to one thing. And that, you can see there's two arrows off of it. It's doing two things. I don't like that. So we're going to change that. So instead of having a Lambda function index something in OpenSearch and publish domain events, what we're going to do instead is we're just going to let that Lambda function live and die with OpenSearch. Doesn't care about the domain events. But instead what we're going to do is we still need those domain events published. So we're just going to use an EventBridge pipe that over to an API destination. The API destination is going to call Momento's HTTP API that'll say, hey, publish this domain event for me and route this to all my subscribers that care. Now let's take a look at what that actually literally looks like if you're going to implement that in JavaScript. So you have your guy, your client over here. Maybe has a web page open. You have these 3 lines of code where one of the lines is a parenthesis and a curly bracket and a semicolon, where he's subscribing to get updates on farm animals, specifically goats. So we have this dedicated topic for goats. And he has an event handler that says whenever a message comes in, give it to me, let me run this event handler off of it. And when that happens, when that code actually executes in this browser session, what happens is that gRPC connection I mentioned earlier gets established between the web browser and Momento Topics. It's acting as that routing layer over there. So he's subscribed to there. So when our friend over there on the left-hand side creates a new goat in our farm tracking system, we go through the standard workflow. The data gets indexed into OpenSearch, but instead we've transformed the data and send it off to that API destination, which means, this is the part that I think is extremely cool, we can add publishing domain events in our applications with literally no compute code at all. A pipe to an EventBridge API destination is just configuration. So we're just adding configuration to pipe these things over. It's literally no logic that you're adding into your app, which I think is very, very cool. So it gets published, it goes over to Momento Topics, which is again acting like that routing layer, and then Topics will route that message immediately over those gRPC connections to the people that care about goats, which I assume is everybody. And one of the cool things that we're going to get to here in a few minutes, but I want to bring it to light at the very beginning, is a subscriber can be anywhere. It can be a web page in a browser. It can be a service in the back end. It can even be some deep container in a Kubernetes cluster. It doesn't matter. As long as it can establish that gRPC connection to topics, you can publish to it and subscribe. It's actually really, really cool, the flexibility that you have. So that's great. I have to address the elephant in the room, which is always security. This sounds really open, and it is, but we have ways for you to scope it down. So with Momento, everything, of course, requires a token, an auth token, and we do access control based on the token that initializes our SDK clients or is passed into the HTTP endpoints. And those tokens have scopes, of course, that you can create, and these tokens are short-lived in nature. They only live like an hour and then they expire. But what's really cool is that we can add these permissions inside of these tokens that say, okay, you can only access data in this cache, or you can only access these topics, which are really flexible magic strings. Again, we'll get to that in a minute. But you can also say, allow this person to only subscribe or only publish or both. You can really hone in on exactly what that person is or isn't allowed to do. And you can do that down to a key level or even a key prefix level. So if you have your topics prefixed with a tenant ID, you can scope tokens down to say only use topics that have that tenant ID leading key. So now we're gonna take a peek under the covers a little bit, because I actually think this is one of the coolest things about topics. We're gonna look simply, this is an oversimplified graph of what a serverless service looks like behind the scenes. Now, there's three major pieces. There's a routing tier, which fields all of the incoming requests. There's a storage tier. You can guess what those do. Those house cache data. It also houses the topic messages. And then you have your control plane. That's kind of the brains of the entire operation. So that's the part that monitors the storage tier for when things get close to full. When alarms start going off, it automatically scales the storage in and out. I have another talk that I give on how the caching service is built, where I go super in-depth into all this. So I'm gonna save the super in-depth for another time, but I do have content out there if you are interested in how serverless caching works. But since we're here to talk about real-time notifications, we're actually gonna slice and dice this a couple of different ways. Really, I wanted to just set the groundwork for what are the three major components, and then we're gonna look at it in a slightly different lens. When we're talking about managing all these connections, all these stateful connections with browsers and services and containers, how does that work? How do we scale that? How can we say we provide serverless capabilities? And we can do that by saying we have a two-tier architecture. The first layer, that routing layer, is the thing that fields all the requests and establishes connections with people out in the field or services out in the field. And internally, all the messages are saved on a storage tier, on our storage layer. And the storage layers are EC2 instances that have a bunch of containers running on them and data partitions, different storage mechanisms inside of each one of those. Now, what's really cool about topics, it's different about things like SNS or other messaging services that you've seen, is that topics are dynamic. You don't have to create specific cloud resources to be able to publish to something. You can, I alluded to this earlier, publish to magic strings, and it works. And how does that work? We actually use a rendezvous hashing algorithm based on the namespace and the topic name and the customer. It all says, okay, well, based on how all this is shaped, we hash it, you're gonna go to this specific storage tier, to this specific container. Again, it's called a rendezvous hashing. Highly recommend if you're interested in something like that. It's a deterministic way to figure out where things need to go. But because we've implemented it that way, you can get unlimited number of topics or channels and don't have to do any resource management at all. It's really good for ephemeral environments. It's really good for dynamically created, narrowly scoped topics. So it's a really cool thing. So we're gonna go through an example. We're gonna, again, look at this architecture in a different way, a simpler way. So I've gotten rid of the control plane. It's not really necessary as far as our example goes. But we have the routing layer and we have the storage layer. Now I have 5 people that all want to track hailstorms in Dallas. If you don't live in Texas, March to July is hail season, and roofers love that. Big hail all the time. They come in at least once a week. So this is actually a very applicable use case because they happen all the time. So our routing layer is round robin. So we have an auto-scaling group of EC2 instances in this routing layer, and it's round robin. So let's just say 3 people come in and they all say, I want hail notifications for Dallas. So they have a very specific topic that they're subscribing to, and it gets fielded by 3 different routing EC2 instances. And they use this rendezvous hash that we were just talking about to say, okay, well, based on the information that you're asking for, that's gonna live on this storage node specifically. So all of the tier 1 EC2 instances are establishing gRPC connections to the storage layer. So it's a 2-tier, almost exactly the same thing from your end users internally inside of Momento. Now, when other people come in and the round robin has restarted, we're going to have multiple connections really looking at the same thing. Now, one of the reasons we use gRPC for these instead of WebSockets is because they support multiplexing, which means you can have shared connections. So instead of building another connection from that routing layer to that storage layer, we're actually just going to reuse what's already there, which allows us to get that really high fan-out scale to publish very, very fast, very quickly. So big advantage of gRPC on that one, especially over something like WebSockets. So here's the stuff that I think is the coolest. This is actually the majority of my job, coming up with cool things that you can build, building them, and talking about them. So let's go through several examples because there are really cool use cases at every level, every type of connectivity that you can use with the same code. So I haven't seen any reactions go up, probably because my QR code is too small. But if you happened to scan that QR code, it will bring you to a page, and it will have just these emojis on it. Thumbs up, mind blown, love it. I have one of Eric's face in there. And you can press these buttons, and it will use Momento Topics to connect a browser session to a browser session. So my page that I'm presenting right here is subscribed to this presentation's topic. And the page that you're routed to when you hit that QR code publishes to that topic. So all it does is just publish that message. My browser picks it up and then displays a very fun emoji or comment actually on the screen. But the good thing to note here, the really interesting, cool, I think innovative thing that we're doing is I don't really have any server-side components to this. I didn't build that architecture that we looked at earlier in AWS. I have, yes, 2 APIs in there that are establishing and creating scoped tokens to initialize my SDKs, but that's it. I don't have any connection management. I'm not doing anything for managing the connections, who does what. I just say publish here, subscribe here, boom, done, and it works. It's really cool, really fun. It took me like 10 minutes to implement that the first time and thought it was just the coolest thing. No server-side components. So let's talk about another one. We're in the US. I gave this presentation one time to people in Europe and Germany, and I said fantasy football, and it's a whole thing. But where are we? We're in Tennessee, so we can actually talk about fantasy football the right way. So fantasy football, what happens here, you have a whole bunch of people that have their fantasy teams. They open the app, and your app code is just iterating over your players. And what it's doing is, as it's iterating over the players, it is establishing connections to topics dedicated to those specific players. So we have maybe, if there's 10 people on your fantasy team, you've opened 10 connections to, or 10 topics. So you've subscribed to 10 different things. Again, dedicated channels. And what happens is, in a real life football game, people play. So let's say that Patrick Mahomes passes for 44 yards. Very realistic scenario. So whatever mechanism is out there on the field reporting all these things does a post to our API gateway. Maybe the data looks like this. Here's the player ID. Here's what they did. Hits that Lambda function, does some compute to calculate the number of points that's associated with 44 passing yards. So it saves it into DynamoDB in a format like that. Preserves a little bit of what came in, but also has the number of points that it was worth. That goes into the DynamoDB stream, and then what we do is we transform that record in our pipe to API destination, pass that over to topics, make it look like this, which is the HTTP endpoint for topics, and then it will broadcast that down to everybody who has Patrick Mahomes on their team in real time. So really what we're doing here is we're passing deltas down. And the clients, the phones themselves, or whatever, doesn't have to be a phone, is responsible for updating the total score. So we're just passing in deltas. But really fun use case, and this is a good example of a server to a client. So the last one that we looked at was client to client. This is a server to a client example. Feature flags, something that we all know probably. And I wanted to provide a good example of service to service. So I drew my best example of what I think Kubernetes looks like. I don't have any idea what it looks like, just to be honest with you. I assume it looks like that. But we're gonna imagine that we have 2 nodes, 2 pods each, 2 containers each. And what each one of these containers are doing as they start up, as they're running their bootstrapping code, is they are doing 2 things. One, it's fetching the current state of feature flag data. Now let me take one step back real quick. If we don't know what feature flags are, let me explain that really fast. Feature flags, really easy way to separate code from configuration. We can configure features to be turned on and off, like if they're in active development. Let's say I'm adding a new feature into my web application, or I guess in this situation I'm doing something in the back end. Maybe I'm limiting the number of threads that are running specific types of background processes. They let you change things on the fly without redeploying. So it's a configuration management system. So what a lot of these configuration apps do, like AppConfig does this, LaunchDarkly does this, all the big guys, is they keep this big object of your feature flag data out there in memory. And then whatever is consuming it just reads off that big object to say, okay, well, let me divert here for this tenant, or divert here for that tenant, show this field, whatever the use case is. So what we're doing is we're loading that big blob out of a cache, out of a remote centralized cache that all these containers have access to, because it's remote and centralized. It's not local on any of them. We're loading that big blob, and then we're subscribing again for deltas. So what's happening is if I change something, what I'll do is I will grab the flag that's changed and then update that giant blob that I have in memory. What that actually looks like as far as an implementation goes is maybe you have your feature flag dashboard. It's setting the color of a background on a web page or a button. It's limiting the number of threads in a background process. But I have a web page. I change it. It goes through. I update the cache. And then I publish the delta to topics. And as I do that, it fans out and goes to everybody at the same time. So we have successfully managed to synchronize state across a fleet of containers in real time. So this is, again, an example of server to server or backend to backend communications with the same mechanism we were doing browser to browser and service to browser. So a lot of capabilities on that. Chat, this one always makes me laugh because chat is such an approachable use case, because you see it everywhere, whether or not you actually realize that's what you're seeing. Like I was on the Home Depot website, like I always am because I live on a farm. And I was searching for the current cost of 2x4s. And I just get a little notification in the bottom right that says, hey, do you want to chat? It's like, oh, wow, okay, even Home Depot has a chat. Everybody has it nowadays. And what I like about chat specifically, at least when we're talking about real-time notifications, is it's a use case everybody understands. And it's a very, very easily solved problem in very much the same way that we were just looking at with the feature flag solution. So what happens here is you have 2 browsers, and they hit the same URL to the chat room. And when you land on that chat page, we have some code that's going to do 2 things. One, it's going to fetch the message history, what happened prior to me getting here out of the cache. And then it's going to subscribe for messages. I want the deltas again. Give me everything that happened so far and tell me when something new happens. So what ends up happening is you type in a message, hit enter, and then that's all the code that you have to run to actually publish a message and get that to go over to all your different connected chat windows. So between, oh no, that doesn't go backwards. Between the subscribe and the publish, we're looking at like 6 lines of code for an actual chat application, which is really neat, with no back-end server-side components. Does that look familiar to anybody? Hopefully some of you played The Sims before. But what you can do really easy nowadays, or now with topics and real-time notifications, is you can pass status updates of long-running jobs in real time as they happen. So, you know, The Sims, they tried to make it fun. I think that talks about like llamas and whatnot, and sometimes it's nonsense what they display on the screen. But you can actually do real, meaningful updates in these longer workflows down to the browser for people that are waiting for long-running jobs. So one of the cool use cases that I saw, I think it was earlier this year, was from David Boyne. He's here today. He was just speaking. And he made an application that creates stories for his kids. It uses Gen AI. There's my mandatory Gen AI reference. It uses Gen AI to actually create the story. It goes and it creates an image that represents the story, and then it translates that, or it does speech to text, text to speech, there we go. So it actually reads the story. So everything is generated for that. And that's a semi-long running process. And if you're waiting for that, if you have a web page or something that's allowing you to set some parameters to go and build a story, and you're waiting for it, you want to know what's happening. I don't want to see a 30-second spinny because I don't know when it's done. I don't know if there's any progress being made. So here's a step function workflow that takes advantage of that API destination we were talking about earlier. So before each one of these long-running steps, I don't know if you can read that or not, but we have a Lambda function calling Bedrock that says create a story for me. Here's some parameters. Before we do that, or I guess after we do that, we just publish an event that says, here's the status, generating story. Continue the process, go down. Now we need to create an image for it. So we're going to drop another event on the EventBridge bus. That's going to go. It's going to publish a status update to all the connected browsers, and it's going to say, hey, now I'm generating a picture for you. It's going to, in parallel, go over and translate the text to speech through Poly. Say, now I'm creating audio for you. And it's just giving you these updates for these things that take seconds to minutes and letting your users know that, yes, things are actually happening and meaningfully, much more so than The Sims. And then when it's done, you can do the same thing. You can publish an event, but you can actually send it to a new URL and make that browser that's waiting redirect to the actual story page. Super cool things that you can do that just keep people hooked. So this is one that actually was surfaced to me this week from somebody named Elias Brange, and it's something that I just thought was the coolest, the absolute coolest use case. I had not thought of this at all, and I think there's a lot of merit to this. So he's using topics to test event-driven architectures in a unit testy, end-to-end test way. So what he does is he subscribes to an event topic. So he's testing to make sure that a domain event is being triggered when he creates a new entity. So he subscribes to a topic dedicated to that, hits the endpoint goes asynchronous, does its thing, it's going to EventBridge. EventBridge, we have a rule that will pick up all the EventBridge messages, publish them to a topic, and then that topic is connected down to his unit test end-to-end test suite. And he just waits for a message. You can kind of see the code over there. He's waiting for a message to come in that matches the format that he expects. And if it doesn't come in the time that it takes for the test to time out, he knows something went wrong. So it's a really cool way to synchronously test asynchronous workflows in a meaningful way. Like, you don't have to manage the topics. You don't have to do any of that. It's all ephemeral and dynamic. So I wanted to point this one out because this is one of the cooler things that I think you can build with Momento in general. And one of the most common patterns that I use when I'm building APIs on AWS is I put a Lambda authorizer on top of my API gateway, as opposed to using Cognito. I mean, you certainly can use Cognito, and the premise applies here, but I use Lambda authorizer a lot. It validates a JWT, and then it loads information about the user that's encoded in that JWT. In a lot of systems that I build, they're role-based. So we do role-based access control, and the return statement out of a Lambda authorizer is a policy. And that policy tells API Gateway that yes, this person can or cannot access this list of endpoints. But it also provides a context object. And you can enrich that context object with like the username, really whatever you want. These are the roles that this person has that you can use in your downstream services like step function, Lambda, and all that. I'm going to assume that you guys do that, and you've already implemented that, and that exists in your apps today. So if you wanted to start using Momento Topics in a meaningful way where you can actually safely limit what people can and can't access, just add the auth generation into your Lambda authorizer and pass that in the request context. Now you have a limited scope token to exactly what the caller has access to that you can use downstream. If you have a get profile API endpoint, you can echo that back in the get profile that runs to a browser and get the same token in the browser that you're using in the back end and really just tie a lot of security into one single token. So it's really cool, super low lift to be able to actually instrument your apps to use these types of tokens to enable this kind of connectivity. Okay. So we're slightly early, but that's okay. We're going to go over the things that we learned. So real-time notifications, there aren't one-to-one WebSockets. WebSockets are real-time notifications, but not all real-time notifications are WebSockets. There's a lot of different other options that you have. Topics can connect to everything. It can do browser to browser. It can do service to browser. It can do service to service. Really, the possibilities are limitless, and it uses the same code. It doesn't matter where you're subscribing or where you're publishing from. It's the same. And then hopefully you guys learned a little bit about how serverless services work. I know I kind of blew through that, but it's a really cool, interesting way of how you can take advantage of some of these technical implementations like gRPC to maximize fan out and scaling capabilities, you know, reusing or taking advantage of multiplexing to scale out connections. So it is a lot of fun to build with this because it's, in a lot of cases, 3-6 lines of code to actually get something that works. So thank you very much.